Welcome to week 5 of the robotics, and also I believe we have the class in here today. Today's lecture is on a continuation of the robot operating system that we went over last class, and also an intro to Python programming language, which I hope some of you already know. Or not, that's okay. And again, the instructor, Patrick Benavides. So, I hope this works. This is all done in Linux today. This is done using an open source version of PowerPoint called, I think, Librarium Press, I believe. So the looks can be a little bit different than, say, a Microsoft version. So, what is Python? Other than programming language. Anybody have any good things to say about it? It's like a snake. Okay, it's also a snake.
It's good for beginners.
Yeah, it's good for beginners. It's also good for, say, computer scientists, engineers, just about anybody that needs to actually do anything in computing and get their programming done quickly. So there's many different fields we use it: scientific programming, engineering applications, cloud computing. Cloud computing is actually a good example. There's actually an API where you can spawn up your servers using Python. It's really kind of nice. So again, we say why people actually use it. It's easy to use. Presents a simple enough API for users to run scripts, rapidly prototype code, create GUIs, and manage data. So first off, how can I get Python, how do I do it? So people are going to ask me that, or ask Barad or somebody else that. And one method that I found the other week that was actually pretty nice was a suite called Anaconda.
The best one, my favorite.
So it's something other than Python. It includes all these extra packages with Python, so you can do all your scientific programming. You might be thinking in the robotics class, why am I doing scientific programming? Well, unfortunately or fortunately, whichever one is the case, ROS also included some of the scientific programming tools. And also, you're probably going to be doing some sort of filtering. You're going to be doing something that would otherwise not just be what you consider a robot, but you might be doing signal processing, you might be doing image processing, you might be doing all sorts of different types of processing for your data that's coming into your robot. So scientific programming is a good thing for you guys to have as well. Everything overlaps in the end. Another method you can do is it's called ROS. So as I told you before, installing ROS is a great thing, even for this class includes ROS automatically includes Python, which is great. It has built-in ROS support for Python in an API called ROS-Pi. Some people think when they see ROS-Pi they discovered something amazing, but really it's just a built-in part of ROS that's stated on the front page. You can also install Python on its own. You can download the Python installer and install it in Windows and try to get started with it. It's probably the hardest approach because you have to do more to figure out, okay, what do I need to do next? Whereas these other methods actually help out quite a bit. And of course, I don't have a pointer that shows the screen in Linux, at least on this one. So there's different IDEs to use Python. You can use Ninja in Windows. It's kind of nice. It's kind of pushes you through using Python. Helps you run your program. I actually prefer either Ninja or this IPython notebook. It's a really, really neat tool. So when you install Anaconda, you have the option to run IPython notebook with command line because it installs that package. What it does is creates a server and it tells you how to access it using your browser. I would suggest Google Chrome. You open up a browser, you type in the address it gives you, and then what you get is an IDE that's in your browser. You don't have to install Visual Studio, you don't have to install some of the other stuff. You install Anaconda once, you get all this other stuff in addition. So the browser is actually pretty neat. A little bit later I'll show a screenshot or something of that. So how do we learn Python? How do people in here learn Python, the ones that know how to use it? No one's willing to say. You looked online? Anybody, raise your hand, you looked online? Okay, so you tried a few examples, you ran some code. You were told this is Python, do it. No? Okay, so the third was actually mine. My approach. Like, here's a Python program, figure out why it's not working in this one point. Okay, what's Python? No, that's how I got pushed into it. I just had to do it. It was for my internship job. So your job will sometimes push you to do something that you don't know how to do. So are you going to say, I didn't take a class in Python, so therefore I cannot do that? That's not the answer. The answer is you figure it out. So one of the you figure it out approaches is learn Python the hard way. That's actually the name of the website. So if you go to this link, hopefully it works. Okay, it doesn't work for me. So we look here. Okay, so if you land on this page, you see a whole bunch of price tags, and you see a whole bunch of wonderful things. This guy's really trying to sell it for himself? Oh, sorry. Okay, let's see where we're at here. Yeah, here's our two desktops. All right, so when you actually go to this guy's website, it's very colorful. He really wants to sell you on his program. You can pay $30 and access material that's actually free. Or you can read. So if you just click right over here in the circle or a couple places where it actually says free, you get all the lessons. You may not get somebody talking to you like you would on YouTube. Some people like doing the YouTube approach. It is actually good. There's some very informative videos. But if you just want a whole bunch of exercises you can go through, this is one that I had to go through for a short course where I had a refresher on Python. It was actually pretty good. So by the time you get to some of the later exercises, you see that a lot of them are actual application examples. So if you want to learn how to make a website, you could actually do something with Python and create a website. That's probably up in one of those examples. I remember having to do that. So learn Python the hard way is one of them. Let me find my sources again. There's also this.
Code Academy.
Okay, I already showed up. So there's Code Academy. How many people have used Code Academy? Good. So if you know how to use this, you can go ahead and use it for Python. It'll put you through several lessons, several quizzes. Actually, probably a good way to do that. Assuming vote of hands that like Code Academy. Even after using it. So that's another way.
And each chapter you have a quiz. After passing each unit, you have a quiz.
So there's this other one, learnpython.org. When all the crazy ads come up on say. But on this one, the cool thing is that you actually get a little editor where you can see what's going on. So if I run this little program, it says hello world. I told you last class that Python's kind of slow. It is not actually this slow. This is going through a service on somebody's server somewhere else. So it is actually much quicker than what I just showed you. Let's get back to the slides here.
The next one.
It just goes very slow. Okay, so if you download Python and you can't find what you want in the different things that you have on your computer for Python, all the different packages, you're going to have to download some more packages. And usually when you find the packages, a lot of people like to use Py in the name, or Python, something. So usually you find the package with Py in the name. A couple examples are NumPy and SciPy. These are actually built into ROS. Very nice, because you're going to be using that later for scientific programming if you like that. Matplotlib. This is a lot like MATLAB in terms of the plots. NumPy and SciPy try to be a lot like MATLAB in terms of numbers, representations, variables, and whatnot. Scikit-learn is a machine learning toolbox, and PyBrain is an artificial intelligence and neural network library. So very useful packages that some of you will like to use in your robots or cloud projects or whatever you have. So let's get down into how do you actually use Python. So Python, like any other programming language, has its own variables and types. There's integers, strings, floats, more complicated numbers. I'll get into a couple of those, and more complicated variables. So here's some examples of using an integer. So how many people know C or C++? What do you have to do to make an integer? And variable name equals whatever, semicolon. So in variable name equals the initial value, semicolon. That's 5 things you have to do. On here you have to make 3. This is the exact reason people like Python. There's a lot fewer things to write. So in this case, your variable name for an integer is equal to 2. So A equals 2. Very easy. People like it. They don't get warnings that they typed it in wrong. The next one, string. So maybe student name equals, and then whatever the name is. Very simple as well. Put in quotes, single quotes, double quotes. Doesn't really matter. Floating point numbers. Again, you just type in the number, like 1.0, or float 1. This shows you that the names of the types can also be used to instantiate the variable. So in this case, we explicitly state that this is going to be a floating point number. Same way, we do the same thing, but we don't write out the word. We can do the same thing here, string, parentheses, hello world. We can do that too. There's actually one case in ROS that we talked about the other day, the twist message, the one that makes the robot move. This, you'll be seeing a little bit later, but it will be twist instead of float. So there's also different operations on variables. There's really numerous or tons of different mathematical operations you can run on a variable in Python that are either built in or with the math package or with the SciPy or NumPy package. So you can make a complex number. So if you put a number in that's complex 5, you're going to get 5 plus 0j. So you get your complex numbers, you get your absolute value. You get a min and a max function that work on any number of variables. So you can put in 5, 10, doesn't really matter. That's what these dot, dot, dot. That's what the dot, dot, dot means after x, y, z. And I state this as a warning, please follow this. You know, I put dot, dot, dot on there just because it's a placeholder. It doesn't mean to actually type that in. Okay, so with Python, one of the most powerful things it has are collections of variables. In C, C++, you have to write out a statement that's probably longer than the width of a page to create a list. And then go through that list to find each item that matched whatever you want. So in Python, it's actually pretty easy. But not only do you get a list, you get tuples, which are combinations of multiple variables of different types even, that are just used. I'll show you an example very soon. You also have dictionaries. Dictionaries are mappings of unique IDs to something. Whatever that something is, could be a list, could be a single variable, could be whatever you want. That's where Python becomes very powerful. If you had to do the same thing in C++, you would hate me for telling you to do it in C++. I'm going to show you guys later what that is, but it'll have to be after class or during the break. So here's an example of a list. Here you could instantiate your list. You can append different things into it. Say we had a list of animals. We appended dog, and we appended cat, and then we appended 1.0. Where'd that 1.0 come from? Oops, we didn't want that, right? So you can get rid of that if you want to. Remove anything that's an integer. Remove anything that doesn't match what you're looking for. So, you wouldn't program this way, but you may have a case where you read in some data that you're looking at a list of animals, of the types, and what you end up with are some floating point numbers spuriously in there for some reason. Maybe your data is bad that you got in some way. So there's different features of lists that you can actually remove, append, and do much higher order things to these lists, like statistics and whatever else you can think of. The next is a tuple. All it really means is multiple things in a single variable. In this case, tuples are used almost primarily in return statements from a function. So you can return multiple values with a tuple. Same way you can do the same thing in MATLAB. So say you had, say you wanted to return your three gains, your KP, KI, KD. You had a function called calculate PID gains that was based off the current state. And then the output of that would be your three gains. And then you can use that to figure out your outputs for the controller. So here's an example of a dictionary. Again, it's just like a Webster's dictionary. One item maps to something. Maybe it maps to multiple things. You have to look in the dictionary for that word and see what it maps to. So in this case, this could be like a set of PID controllers for a robot. Depending on how close or far away you are from the target, you may want a different gain value. So in this case, it's a description of a controller in relation to its related variables. That's what the blue is the key, the red is the value. So here's a snippet of code that would actually be used for that. So say if you have get distance from object as a function you create, and then you want to know which controller you should use. So the distance is greater than 10, your range is far, so therefore you'd use your PID controllers from the far controller. Or if your distance is greater than 5, you're going to be at the medium controller, which therefore you would use the gain from the medium controller. And it's just a very simple method to change between two controllers. Okay, so how many people know how to use an if statement? How many people think it's a loop? If you say if loop, please look it up again or see me. Because it's not a loop. In C++ or C, you have braces that go on your conditional statement. So you had something like, if A greater than B, you would have something like this. And then you can use braces if you want to, you can put multiple things. And then you put something here that you would be doing if A was greater than B. In Python, in this case, say if you want to do something, if you find an item called needle on a list called haystack, you can do something as simple as what you would say out loud, if needle and haystack do something. So that's really all we're saying right here. If the string needle is in the list called haystack, do something. So that's extremely simple in terms of a function. One thing to notice, you do not have braces on this one. You have indentation. Python works on indentation. A few spaces, a tab, whatever you want to use. Be aware that it does work different. And it may give you some headaches later on when you have to find out why the program's not working, and it might just be from indentation. So, little note right here, do not forget this colon that is right here after the listening haystack. If you forget that, it won't actually work. It will actually complain and kind of fail like you're used to with C or C++. So here's a more complete example. If keys are in haystack, find keys. You can't deal without your keys if you're trying to drive your car. If your car is in your haystack, you probably have some really bad friends. So you have to move the hay off your car. Else, look somewhere else. So you can't find your car in the haystack, you can't find your keys, go somewhere else, look somewhere else for your car and your keys, depending on what you're actually looking for. So, I don't know if that's happened to anybody in here at all, but that's just a weird example that came up. Okay, so in Python, you get the typical, not equals to, does equal, not, less than, greater than, less than equal to, greater than equal to, but you also get is, not, and, or, and, in. And there's probably a few more as operators for your conditional statements. The previous example that we saw was the in operator. And it would be extremely useful to those that want to use anything with a list, to use that in operator. It's really powerful, and we're seeing it everywhere in Python. But please note, if you have bad data, which sometimes you will get with Python because you don't really check what you're getting half the time. If you have a variable, a string called letter grade, and you read it in from a file, but it actually contains the word alphabet. If A is in letter grade, then the GPA for that person is 4.0. So if you read in alphabet for somebody's grade, they get a 4.0. It's bad data. It doesn't mean that they actually had an A. But be careful. You should see if it's only an A, only one character, or only whatever. You need to check whatever you're bringing in first. So if the robot distance is the word dog, that's not a good thing, right? And you just cast it to an integer and you see what it is and it's some random number. But really you're just bringing in some junk. So do check what you're actually doing. So for loops. Of course, I hope everyone knows what for loops do by now. Yes? Yes. So for loops basically repeat until the condition is satisfied, usually to iterate through a list or an array. So show you how Python does it. These two lines will actually go through the entire list and print everything out. It's that little sort of animation. So the first line for line and list of lines actually states that we're going to select the first line in that list of lines and then do whatever you want with it. And that is also your condition for when you will stop your for loop. So basically, you're going to go through every single line, one at a time, iterating through them. And that's what the one box said on the previous slide. So after the statement print line, the variable line now contains the next item in the list. So the iterator just moved down one, and then you have the next line in that list of lines. You may be reading a file, maybe accepting some data from an internet source, maybe some sort of wireless communication that you have between your robots if you don't use a mouse, whatever you might have. So of course this repeats until all the lines in the process, and it's a very, very simple statement for what it is. You know, C++ you can do it with 2 lines, but it's even looks more simple in this one. Because otherwise, if you have an actual C++ list, you will be doing a lot more work. So again, do not forget the colon at the end of the condition. It is very necessary. Okay, so how many people in here use functions in any of their code? How many people have no functions at all, just like 60 pages of raw code that you can't even read? Thank you, bro. So functions are necessary for others to actually read your code, and they're also necessary for you to read it too. So let's create a little function called generate secure password. A, B, and C are the inputs. We're going to return a string of whatever those characters are concatenated together. So let's just say the most secure password in the world is put into this function, or the combination is put in. So your output's 1, 2, 3 in a string, not numbers, a string. So that's a very secure password, right? How many people's password is 1, 2, 3? Change it, please. Okay, so classes. How many people even know what a class is? Object-oriented programming. Very few, unless you're taking like C++ or some sort of Python course. So in C++, Python, whatever object-oriented programming language that you're using, classes are good if you want to reuse your code. So let's just say you made a security class with an improved function for your secure password generation. So there's a couple different things going on here. There's the constructor for the class, basically sets up the different parameters. And then you have a function inside your class, A, B, and C, returns a more secure password. Does anybody know what self is? This word self, it's just right here in the function, it's also here in the constructor. Even people that use it don't know what it is. It's basically like a storage variable inside your class. So if you want to reference that particular variable, instead of what is actually being passed in, you would use that. So here's your parameter to your constructor, seed number. You can have an internal variable called seed number, which can be set to whatever the parameter is. Very useful. It's a lot like this pointer in a C++ class. Anybody seen that? Okay, so to actually instantiate the class, which whenever you use the class, you make an instance of the class and use it. SCP is the instance of the class security, and the parameter is 345, which went in as a seed number for some sort of secure operation. And then, to get your password, you have to call the function, generate secure password, and pass in the parameters to that function. And then you have your new password. There's actually an underscore here, you can't see it. Okay, so here's where I'd like to, we're at the pausing time right now, Brock? Okay, I'm going to probably show you a couple examples on the command line real quick before we take a camera break. So here's that command line that I told you about. And otherwise, this is Ubuntu. Close. Well, Ubuntu is with a whole lot of purple whenever you get to it. So, last class I told you there's a whole bunch of things you can do with the ls command. You can show what's in your directory, you can sort everything, you can make everything work the way you want to. Say we can make a directory called testing and change into it. What are we going to do in here? Why did we just do this? Where are we going to put our code? How are we going to code things? Yeah, so we created a folder to do something with. And then say we want to create, I use gedit a lot. You can also use nano, I'll show you the difference. Gedit, my full program.py. Right? So some people just like to press enter right now. I also add ampersand. Ampersand lets you continue messing with the terminal after whatever it is that you created has been opened. I've already been messing with gedit, so I already had a window that was open, so I didn't open a new one, and just continued on the one that I had open. So then here, I can never remember, but I'm pretty sure it does something like this. You always want to add this to the first line of your file. And the reason being is that whenever you type in Python code, it'll look like Python code as far as the highlighting. I think I typed in the right way. So say we had a variable called A, and that was equal to 5, right? Or whatever I typed. B is equal to 2. So then you can do something like print A plus B. You can print minimum of A and B. And hopefully everything's working as far as I'm typing. And here's how you can actually print to the command line. Okay, so how do I run my program? Type in Python, my full program. Should not have actually worked. Does anybody know why it should not have worked?
We should have changed the executable.
I should have made it actually executable.
Yeah.
So for some reason my computer did not make it executable. So A plus B is equal to 8. The minimum of A and B is 2. So I'm assuming A was 6, from what I can tell. So Python is actually extremely simple. You do not need to put so many extra things in front of your Python code if you don't want to. There's a way to actually make a main. And I believe it's something like, oh, I have to look it up sometime. I have another one, I can show you that. But it's basically like if the name of the program is main, then go ahead and run whatever code is in here. So let me give you an example of a function. I'm going to find my cursor. There you go. So def add A and B. So here's a function. Python is extremely easy. People really, really love it because. So I think we can cut it right here for the video, and we'll get back to the next part.